What's up guys, Onmaths here, and today we're looking at circle theorems. Now, a little bit of a warning before we start. All of today's 3 questions will be grade 7, but probably most likely the grade 8 section of the papers. So there's not going to be any nice, easy circle theorem questions. And generally speaking, on the exams now, they don't really have many questions that are kind of the grade 6 territory of the exam. So these are the ones, these are the questions you're more likely to have to tackle. So we've got a couple of proved questions, but this is probably the nicest of the 3, since there's no proof or anything. We're just finding values. Now, weirdly, on this paper, you didn't get any marks or lose any marks if you didn't write down the reasons. However, I would strongly recommend you write down the reasons every time on these circle theorem questions, because on most of the questions you get the marks really for the reasons, not necessarily for the actual answers. So the most important thing we realise with this question is that this shape here is not a triangle. Now, I know that seems blooming obvious, but there are 2 circle theorems that we can't use. One for A, one for B. The circle theorem that probably comes into mind for A is the angle at the center the angle at the circumference is twice the angle at the center. But we don't have a triangle coming from DC touching the circumference. So what I imagine some people would do is get that 82 and halve it, but we can't do that on here because it's a quadrilateral, it's not a triangle. There's something you need to notice, and the thing you need to notice with this question to find out x is that OD and OC are both radii. Now, if they're both radii, it means that they're equal length, which means triangle ODC is isosceles. So we can work out that angle OCD equals 57 degrees. And I'm just going to say that triangle ODC is isosceles. Okay, and then so therefore x equals 180 degrees, take away 57 times 2. And the reason for that is, or why we're doing that is angles in triangle add up to 180 degrees. And so this is paper 5, and on paper 5 for OCR we don't have a calculator, but we can do that. So that 57 times 2 is going to be 114, and then 180 take away 114 will be 66 degrees. So the answer to A is x equals 66 degrees. Should probably put degrees there. Although degrees is in the question, it has a degrees next to it, so we don't need that degrees. Okay, find the value of y. Now, again, it's really tempting for the value of y to write down e to 2, and the reason for that is alternate segment theorem. And you think, oh, okay, it's alternate segment theorem. Absolutely wrong. Because, again, that is not a triangle, that is a quadrilateral, so you can't use alternate segment theorem. Alternate segment theorem is where you've got a triangle coming from point D, touching the circumference at each of its sides. We don't have that. We do have a triangle coming from that point, kind of, but it's not resting against y. Like this one here is not resting against y, and it's not got all 3 of its points at the circumference of the circle. So we take that out of our mind. It looks like it's alternate segment theorem, but it's not. We can't use it unless we draw a triangle from it, but that's not going to help us because we don't know any of the angles in that triangle, so we abandon that plan. Something we do know about quadrilaterals in circles is there's something called cyclic quadrilateral. Now, this is a cyclic quadrilateral, and you know it's a cyclic quadrilateral because obviously it's got 4 sides, but each of the points on it touch the circumference, so that automatically makes it a cyclic quadrilateral. Now, what we know is that opposites in a cyclic quadrilateral add up to 180. So this one and this one add up to 180. I'm going to do my working up here In the exam, you would obviously do it under where it says B, but I just think it's easier to write the working out with the question. Maybe I can move it afterwards. So we know that angle ADC, which is this one here, equals 180 minus 82. And the reason for that is cyclic quadrilaterals. Okay, so that's going to be, was it 98 degrees? Now I can work out ADO, so I'm going to do that next. Angle ADO, and that's just going to be 98 take away 57. There's no reason for that, it's just logic that if that whole thing is 98, we take away the 57, so we don't need to write down a reason. And that equals 41 degrees. Now another circumference we know is when we've got a tangent coming from a radius, they will hit each other at 90 degrees. So this is going to be 90 degrees here. In fact, let's choose a different colour. This is going to be 90 degrees here. So angle ODE equals 90 degrees. Angle between tangent and radius, and therefore to find y, all we need to do is do 90 degrees. In fact, let's just do 90, take away angle ADO, so that's 41, and that would be what, 49 degrees. So a lot of working out there. Now some of you might be saying, oh, I've found a different way. Okay, sometimes with circumference there are different ways of doing it. This to me seems the most obvious way of doing it, but if you've found a different way of doing it, write down in the comments below. But you can see why it's 3 marks, because there's just an extra step of working out for this question. Next we move on to AQA question, and this one is a prove that question. In fact, the last two are prove that. With this question we just need to figure out what circumference we need for the question. So it says work out that QS, which is this one here, is not a diameter. So we've got to figure out what would be the case if it was a diameter. So assume that QS is a diameter. What circumference or other proofs could we use with it? Well, the main one for circumference for a diameter is that any angle that comes from a diameter will be 90 degrees. So we have a look at this diagram and figure out where that angle would be. Well, that angle would be this one. So if that was a diameter, QPS would be 90 degrees. So the question really is QPS 90 degrees? That's all the question, because if we prove that it is 90 degrees, then QS is a diameter, but clearly we're going to find out that it's not 90 degrees. So we're going to break this angle up into two. We're going to have a look at this one first. So angle QPX. And the way we find that is that we've got two angles coming from the same chord, this one and this one. Therefore this angle and this angle are going to be the same. Okay, so that's the circumference we're using. So that's going to equal 27 degrees, and always write down the reason, as I said in the previous question. Mostly you get the marks for the reason. Angles in same, we don't really have a chord there, so it's angles in same segment are equal, something like that. Okay, so that we know is 27 degrees now. So we need to work out this one here. Okay, Now this is going to be the same as the previous question because we've got an isosceles triangle there. So we can work out what XPS is going to be. So angle XPS, and it's going to be 180 degrees. Put that into brackets, take away the 50 that we know about, so we know that's in the triangle, and then halve it because the remaining angle will be shared between XPS and PSX, so this one here, because they're going to be equal because it's an isosceles. Now this is going to be non-calculator, so it's paper one, so it's 180 take away 50, which would be 130, and then that's going to be, what's it, 65. So XPS is 65, and so we know that's 65, and the last step is we've got to work out what angle QPS is, because we're hoping that's 90, or hoping that's not 90, otherwise we made a mistake. So it's just the 27 plus the 65. And that is 92 degrees. Right, the last thing we need to do is just say so angle QPS is not 90 degrees. Therefore, QS is not a diameter. Now the last thing I do is I just double check and see whether I've written down all the reasons. Now we have used a fact, but we've not written down the reason, so we just need to go back and sort that out. We used angles in a triangle, and I don't know, base angles in isosceles are equal. Now I would normally recommend that you write down the reasons separately. I've kind of combined them there, which I kind of don't like, so what I'm going to do is I'm just going to separate them, and the reason why you separate them is some markers only read the first bit and go, oh okay, they've got that one but they haven't written the other one, so you just need to be really clear about it. So I think that's right, isn't it? Yeah, that looks good. I don't think I've used any other facts, but I would imagine with AQA there would be a mark of the 4 for the reasons, and yeah. Okay, last up is our Edexcel question, and this has removed all circle theorems from our knowledge, and unfortunately we can't use any circle theorems, and we've got to prove that angle ACB is 90 degrees. So this is basically something you just need to sit and learn. There's quite a few of the circle theorems have proofs like this, where you don't use any circle theorems, or you only use certain ones to prove something. So I'd like to say that you'd be able to just sit here and work it out, but I think it's one of those things that you just need to sit and learn and prepare for. And the first thing to do with this question is to draw a line between O and C, if I can do it properly. Okay, and unless you knew to do that, it's very difficult. But there are only 8 odd circle theorems, so just try and learn the proofs as well. Okay, the next thing you do is realise that these are isosceles triangles. Okay, and what we're going to do is we're going to label this angle here as x, and this angle here as x, and we're just labeling them as x because they're the same, and I've just picked x. You could label them whatever you want. It's traditional to label these x and this one y. Okay, and again, this is an isosceles, so we know these triangles these angles are the same. And then just go through the bits that you can work out. Well, first of all, the whole triangle in itself. So the angles in the full triangle are x plus y plus y. And we know angles in a triangle add up to 180 degrees. So we've got this kind of equation going on. So was it 2x plus 2y equals 180 degrees. And we've got this angle here is going to be angles in a triangle add up to 180. There's 180 take away 2x. So it'd be 180 take away 2x. And this one here will be 180 take away 2y. Again, angles in a triangle. So we've got angles in a triangle add up to 180, and we're removing the 2x's we know, or the 2y's that we know. But the whole thing is angles on a straight line. Angles on a straight line add up to 180. So we've got 180 minus 2x plus 180 minus 2y, and we know that adds up to 180. And if you rearrange it, you get 2x plus 2y equals 180. So you can see you can use either way. Which is easier? Or almost certainly this way. That would be my method of choice. But you can use either way. So if you accidentally go down the wrong path and work out the middles, it still works out. It's absolutely fine. Now, something interesting we can do with this equation is we can just divide everything by 2. So we're going to divide everything, and remember you've got to divide all the terms by 2. So we're just dividing everything by 2. That would leave x plus y equals 90 degrees. It's that simple. So I would say that ignore all this middle bit. I wouldn't bother with it. A lot of teachers teach it this way, finding the middle bit. But you don't need to. You can do it all through just the x and y's there, and just completely ignore that bit. And that's probably a nicer way of getting the 4 marks. 4 marks just for a little bit, just for a line down the diagram. Now, I would also heavily recommend giving reasons, because we know there's going to be marks for it. So how would you go about that? Well, I would say something like angle OAC equals angle ACO, base angles in isosceles are equal, and I'd probably include angle OCB equals angle CBO in that. It's the same reason. I probably should write isosceles triangle. Not that there's other isosceles around. In isosceles triangle are equal. You can never write too much with the reasons. It's just that with doing these videos I try and keep it brief, but you know. The next thing is what we've used here is the angles in a triangle add up to 180. So kind of in there I'd write down angles in triangle sum to 180, and what sum means is just add up to. Now, if I took the other approach, I wouldn't use angles in a triangle. I would use, I'd use angles in a triangle and angles on a straight line, but I've chosen not to use that. That's the more complicated approach, and it's kind of unnecessary. As you can see on the left-hand side, that working out is much, much more simple. Well, I hope you found today's video useful. If you did, please click like. If you want to see more from us, release videos every single weekday at 9 o'clock in the morning. So just click subscribe and the bell icon to make sure you're up to date with all the videos we release. If you want to see even more from us, click the link that appears magically at the top of the screen. That will take you straight through to our website, onmaths.com, which is packed full of completely free resources to help you with your maths. Please keep the comments coming in. Summer school will not last forever because we will run out of topics. So keep suggestions coming in of stuff you want us to cover. Otherwise, thank you very much, and I'll see you tomorrow.